guys, welcome back. This is Abhishek and welcome to my YouTube channel. So today we will be talking about outlier detection. So there are lots of videos I have already uploaded on YouTube for outlier detection tutorial. I have gone to all videos and I have found that there is something which I should tell you, some extra knowledge of outlier detection, and that's why I'm creating this video. So I have worked on Kaggle competition and I have got some personal experience which I will be sharing with you. And so let's get started. So if you haven't subscribed my channel, please subscribe because we upload data science and machine learning videos on daily basis, and you will be get notified. So first thing first, for outlier detection, we are using Boolean dataset. Since this Boolean dataset is mixed type of dataset, means it contains categorical and numerical and columns both. And if data is not very big enough, and we have to whenever we do outlier detection, we have to take so many uh, we just cannot afford losing information, because if we remove all those points saying that these are outliers, we will lose information and our data is not big enough. So we have to take care of these things, so we have to retain enough information. Okay, so this was just and just the information. So what I have done here, I have just separated out x and y, and after getting a data set, after ensuring that there is no null values, what you do, you separate the data into train and test. You basically split data, and there is train data and test data. And you can see that our train data, I have just 404 rows. So keep in mind, just keep in mind that we have 404 rows. Okay, because we will compare that how much information we have lost, so that's why keep in mind 404. Okay, I have written out a question: does outlier affect every kind of model? So I would say yes, because just other model like XGBoost and LightGBM, they are very robust model. They kind of does not affect by outliers so very much, but it's always a good practice to remove outliers, because we do outliers, and keep in mind that we really need not to lose so many information. There is a trade-off in between outliers and information. Okay, I will tell you how do we adjust all those things. Okay, we are using three type of method. One is isolation forest, and second one is interquartile, and third one is G-square outlier detection. So you may have already familiar with interquartile, G-score, and isolation forest, but there is something different um, process for applying these. Okay, and those process will be really very simple. You have to just understand codes line by line, and you have to just apply. Okay, and again, outlier detection only works for numerical data. Don't touch with categorical data, otherwise you will heavily lose information. What I'm talking about, if you have a column. Okay, if you have column and I'm saying 1 2 3 and there is 6. Okay, so we don't know why what these numbers stand for, but we can say that this is categorical column. Why we are saying categorical column? These are numerical, these are d type numerical, but we are saying that these are categorical type column, because whenever a column has any unique is less than 10 or 15, means less than 10 or 15 unique values, then we say that this is our categorical column, and we make dummy variable of them. Okay, so if you will have a column having less than 10 or 15 unique value, you will definitely say that this is our categorical column, and you will make dummy variable of them. Okay, that's why and okay, if we apply our outlier detection method on this, then definitely that will remove our 6. But 6 contains lots of information in this column. That's why we don't apply numerical that's why we don't apply outlier detection on categorical data. Okay, and one remember one thing, again it's really important that when you split our your own big data into train and test. You whatever process you apply, it could be outlier removal, it could be your uh, removal of skewness, it could be your let's say you apply outlier detection, you apply skewness and other thing. Whatever we apply only on trained data set. Okay, we don't touch test data set, we work only on trained data set. So because we cannot expect what kind of test data fit we may get, we apply outlier detection, we apply undersampling, oversampling, we apply removal of if skewness by using box cox method. Whatever we apply, we just work for trained data set, we work on trained data set, we don't touch test data set. Okay, so here we have separated out our numerical columns and categorical columns by saying that if number of unique values will be more than 20, I would say that it's our numerical columns. So I'm just calculating the number of rows here, so I have got 12. So I'm creating a data frame of them saying df num means numerical data frame, and then I'm creating a box plot by by writing this line of code. And here I'm just by using list, or by using creating a list and of all columns, and then loop, two loops, nested loop for giving accesses location, and you will be able to see we will get something graph like this. Okay, very important thing, let me tell you that suppose you may have something like this. Okay, can I say these are outliers? Definitely I would not say these are outlier, because there is a trend. What trend is that all point which ever on this line are not unexpectedly, this point comes and then after this point and then this point, so every point are following a pattern, they are almost equidistance, you can say. So these are not outliers. What outliers is, let me tell you, a point which comes unexpectedly, so that will be outliers. So suppose in this graph, in this box plot, you can say this is outlier, you can say these are outliers. Okay, and in this point there is no outliers, you would say. You can remove all these things, but again you will have to pay the price, you will lose a lot of information, your model may underfit, and that's why we don't remove all these. Wherever we will have many points. So this is our understanding. So you really need not to adjust all these things, and it's a pretty straightforward, you don't need to do this. I'm telling you what you really have to do. Okay, so there is first method, isolation forest method. For this method used for outlier detection, we don't use we can use it for outlier removal, but basically we use for outlier detection. Here I am creating a data frame, my own simple data frame, and then I'm calling in symbol isolation forest, then fitting our data. I'm reshaping it since it's 1D. And if we want to know that our 5345 is outlier or not, then we have to predict it. If it gives you -1, it means it's an outlier. If 1, then it's not outlier. So the second method is really very important method, named as IQR, interquartile range. So if you don't know what interquartile range is, you can Google it, but let me tell you what it is. So this is box plot, we read it from here. This is 0 percentile, this is 25 percentile, this is our median, or you can say 50 percentile, and this is 75 percentile, this is 100, and any point. And this is Q1, since this is 25 percentile, we say it as Q1, and this is Q2, and this is Q3. Okay, if we minus Q1 minus Q3 minus Q1, we get IQR, so this will be our IQR. Okay, so what we do, we say Q3, let me write it, Q3 plus 1.5, let me write 1.5 into IQR. So just tell me what values this will be IQR. So IQR means this range. So Q3, this point is Q3. Q3 plus 1.5 IQR, this will have a range of this. So on this range, if any point comes beyond this range, we will say outlier. So these are outliers. And again, if we replace Q3 to Q1 and plus to minus, then we get a range from here. And any point comes below this range, then we say that these are outliers. Okay, so this is really very simple. So what we are doing, we are first calculating our 25 percentile and then 70 percentile, then we are subtracting it, then we will get our IQR for every columns. And then what we are doing, we are selecting all those points, we are selecting all those points uh, who lie between, let me tell you, who lies between this range and this range. We are selecting all those values which lie between this and this. And if a value comes here, then we will say outliers, and then if value comes here, we will say outliers. So we are calculating IQR, and then we are selecting all those values, df num, and then our tilde sign which represent not, and then we are selecting all those values which are not below q1 minus 1.5 IQR, or which are not above q3 plus 1.5 IQR, and any axis equal to 1, we are mentioning axis equal to 1 to represent that this is column voice. And then just run it, and you will be able to see that initially we had 404 rows, and now we have 244 rows. Now it means we have lost much information, and we had only 404 rows in test data. So to retain more data, what we have to do, we have to only remove extreme outlier. So how do we do that? We remove only extreme outlier by increasing this k value. I can say it's 1.9 and increase it to 1.9, and you will be able to see that now we are retaining much data. Okay, so in this way we remove only extreme outliers, and then again we are plotting this box plot showing you that we have removed our extreme outliers. And the third method is our GScore method. So before telling you GScore method, let me tell you what uniform distribution and how does it look like. So here, this is our normal bell curve here, and you will say these are our GScore values: -3, -2, 1, 0, 1, 2, 3, and you will be able to see that our 99.7% of our values belongs between -3 to 3, and whatever value comes above 3, whatever comes value is greater than 3, I mean whatever value comes in this area or in this area, we will say that these will be our outliers. So if G score will be greater than 3 or G score will be less than -3, we would say that that value will be outliers. So again taking mod, so if mod G is less than 3, then we will say it's not outlier. If mod of G is greater than 3, then we would say that these are outliers. So I hope this is clear to you. And the same thing we are doing here. We are using SciPy for calculating of Z-score and then np.abs to take mod of Z-score, and we are passing our data set, and that will return me again a G-score day having all the point, like every value will have their unique G-score. And then filter entries here, let me show you what filter entries is. Filter entries basically a list of all true false values. Look at this, and what true false values means here. Suppose this is our data set. Try to understand, this is our data set, and in this data set we will have so many columns, and in every column we will have so many values, and every values will have their own G score. Okay, axis equal to 1 means column wise. Okay, so suppose this is our data. Here suppose this data set will have their G score, and suppose this column have 3.1 G score, and all those are 2, 1 and 1.1. So if this row have 3.1 means G score is greater than 3, means this G score is less than 3 condition not satisfied, so it will return false. Let's come to this row, and if every point, every values in this column is less than 3, then it will return true. And if there is 3.1, and then it will return false on this way. Okay, so the same thing we are doing here. Filter entries will be Boolean list. So it will be if we will have 404 rows, then we will have 404 Boolean entries, and that will be uh, telling us which row we should choose. So that's why we are choosing our rows by uh, dfnum, because dfnum contains only and only numerical data. So that's why we are, and then we are printing out. So we will have a data set like this. Now numerical train is only our data set containing numerical columns, but our this data set have removed, this data has no outlier, this data set has no extreme outlier, and we have successfully retained our enough information. Like at initial point we have 404 rows, and right now we have 360 rows. Okay, so we have just plot some box plot here. And now what we do, we have just here we have numerical train 2. This is a data, this is like we created this data numerical train 2. This is a data containing all numerical columns and having no extreme outliers. So these index, on the basis of these index we will choose our rows from our original data set. So right now we are choosing our original data set by passing our index values, and then we will get a data having no outliers, no extreme outliers. And right now this is 360 rows and 14 columns. So in this way we have retained enough information, and we have removed extreme outliers. In the whole notebook I have used three method: GScore method and IQR method, but I would prefer you to go with GScore method, because in this method you will remove only extreme outliers and you will not lose much information. So again you can change, you can manipulate these values based on your data set. If you will decrease, then your more outliers will be get detected. If you will increase, then less outlier will be detected. Less outlier will be detected means you will retain much information. So it's all, that's all for this video, and whatever I had prepared for this notebook. So thanks for watching this video. If you like this video, if you have any questions related to this notebook, this video, you are feel free to ask me in comment section. I would reply you as soon as possible. And take care. We will see you tomorrow in another video. Thanks for watching.